During this segment of our course, we will deal with the cleaning, inspection, and repair or replacement of parts after the turbine has been disassembled. The procedures we show you now may vary somewhat from one plant to another. Your instructor will clarify any variations now being followed at your plant. The first step in the operation is to clean all of the parts thoroughly, using the method approved by your plant. This phase of the operation is very important, since it is intended to expose excessive wear or damage. Once the cleaning is complete, inspect each part very carefully. If you locate wear or damage, determine whether or not the part should be repaired or replaced. There is one assembly that should not be repaired. It is the overspeed trip pin assembly, shown here. If any of the parts are worn or defective, replace them with factory replacement parts. Do not attempt repairs. The overspeed trip pin assembly is extremely important to the safe operation of the turbine. This is the reason parts are replaced instead of being repaired. Next, inspect the nozzle ring in the turbine case for steam erosion and determine whether or not replacement will be necessary. The nozzle ring is not normally removed from the case unless it has to be replaced. The stationary reversing buckets in the turbine case should also be inspected for damage from steam erosion. Again, as with the nozzle ring, the stationary buckets are not removed from the turbine case unless they must be replaced. The buckets on the turbine rotors must also be inspected very closely for damage or wear. Watch for steam erosion or an excessive buildup of scale in the buckets. If they are beyond repair, the buckets and the rotor are usually replaced as a complete unit. The rotors themselves are not normally removed from the shaft unless the rotors or shaft require replacement. However, they should be inspected very closely. The next step is to lap the valve seats to ensure a good seal when the valve is closed. We'll begin with the constant speed governor valve seats, being pointed out by the workman. First, he must apply a light coat of fine lapping compound to the valve seats, as shown here. Then he positions the valve against the seat and exerts light pressure. To lap the seats, he turns the valve in the seat, maintaining the pressure. Once the lapping is complete, the valve should be removed and cleaned thoroughly with a cleaning solution. Use the same solution to clean the lapping compound from the valve seats. After the lapping compound has been removed, inspect the valve seat to determine the contact. Most plants require nearly perfect contact between the valve and the valve seats. Your instructor will tell you more about the requirements at your plant. You would then repeat the procedure with the overspeed valve. Apply lapping compound to the valve seat. Lap the valve by rotating it in the valve seat, maintaining a steady pressure. Then remove the lapping compound from the valve seat and the valve, and inspect the valve and valve seat to ensure that contact between the two meets the specified requirements. This is the final valve seat that must be lapped. We call it the upper valve seat. It's located in the cover of the overspeed valve assembly. The beveled shoulder on the upper end of the valve fits in the upper valve seat. These parts must mate very closely to prevent steam leakage along the valve stem during operation of the turbine. As with the other valve seats, the workman applies lapping compound to the seat. He then slides the valve stem through the hole in the cover and seats the beveled shoulder in the upper valve seat. The lapping of the seat is accomplished in the usual manner, by turning the valve in its seat. After the lapping is complete, he cleans off the lapping compound and inspects the mating surfaces carefully to ensure a near-perfect fit. Once all valves and valve seats have been lapped satisfactorily, the workman is ready to move on to the next step of operation. This phase of the operation is centered around the shaft and rotors. First, the workman cleans the centers in both ends of the shaft very carefully and inspects them for damage. He then installs the rotor assembly between centers in a lathe for further inspection and checks. He polishes all of the shaft surfaces very lightly. This will allow more accurate measurement and will help to expose damage to the shaft. You must be very careful, though, not to remove too much metal during the polishing, since the tolerances must not be changed. After you have completed an inspection of the shaft, take a close look at the seal sleeves to be sure they are not damaged. If they are, it is a good indication that you have a problem with your bearings. Now, using an outside micrometer, mic the coupling fit to be sure it meets specifications. Then check the bearing fits to be sure they are all right. The outside diameter of the seal sleeves must also be accurately measured. The packing fits are also on the list of fits to be carefully measured and inspected. The final measurement to be made is of the governor case fit on the shaft. Mic it carefully and compare your readings to the manufacturer's specifications. The turbine shaft must also be checked for straight, as the workman is now doing with his dial indicator. The next step will be to check all of the shaft fits for run-out with the indicator. By all the fits, we mean that you should check all of the shaft fits that you mic'd a few moments ago. This includes the coupling fit, shown here, bearing fits, seal sleeve ODs, packing fits, and the governor case fit. Check the run-out for each fit against the allowances set forth by the manufacturer in the turbine manual. The final indicator check to be made is of the face of the rotors. Check both of them for run-out. The last step to be taken also has to do with the rotor assembly. It must be checked for dynamic balance, as the workman is now doing. Your instructor will explain this procedure, as it is now used at your plant. In most cases, the soft packing and the carbon ring packing will be replaced. However, there are instances in which the old packing can be reused. One item that is nearly always replaced is ball bearings. Although your plant policy may dictate otherwise, ball bearings are almost always replaced every time a turbine is disassembled for repairs. Complete all other orders of repair and replacement parts as required. Ordering replacement parts or materials early will save time because they will be on the way while you are completing other repairs on the turbine. Order early and save time. We'll be back to show you the reassembly of this turbine after you complete exercise number 4 in your workbook. During this segment of our course on steam turbine repair, we will reassemble the turbine. As you know, the turbine was completely disassembled earlier in the course, and the parts were cleaned, inspected, and repaired or replaced according to their condition. We are now ready to put the turbine back together. It's a good idea to reinstall the leaf spring first, to preclude the possibility of forgetting it later. The spring is placed in the bottom of the rotor locating bearing fit of the case, as shown here. Now place the overspeed trip plunger back into its fit. The next step is to slide the oil rings back onto the rotor shaft, as the workman is doing here. He places them in the approximate position of operation. This is the new replacement bearing for the old rotor locating bearing that was discarded during disassembly of the turbine. The workman is heating it on this induction heater so it can be reinstalled on the shaft. Once the bearing reaches the required temperature, the workman slides it onto the shaft, as shown here. The shielded side of the bearing is facing the governor end of the shaft. This is an important point. Don't forget it. Once the rotor locating bearing is positioned against the shoulder on the shaft, this retaining ring is snapped into place to prevent the bearing from moving. The beveled edge should be on the side away from the bearing. After the ring is in place, allow the bearing and shaft to return to normal temperature before continuing the reassembly. The next part to be installed on the shaft is the governor case. Heat it evenly and very carefully. Then slide it into position on the shaft. Don't forget to align the set screw hole in the case with the countersunk hole in the shaft. Hold the governor case in position until it cools sufficiently to grip the shaft by itself. After the case is cooled, install the set screw and tighten it down securely. Then prick punch the case around the set screw, as shown here, to hold it in place. The governor case must now be checked for runout to be sure that it was installed correctly on the shaft. To do this, the workman is using a hoist and slings to lower the rotating assembly into a static balancer. He then uses a dial indicator to check the runout of the case. Check the readings against the maximum runout allowed as specified in the manufacturer's manual. After checking the case for runout, transfer the rotating assembly back to a cradle with a hoist and slings, as the workman is now doing. Make sure the governor case is in an accessible position, since the next step will be to reassemble the overspeed trip and the constant speed governor. First, the overspeed trip pin is lowered into its fit in the governor case. This would include an auxiliary weight if the assembly required one in its operation. The pin is then locked in position with a U-lock staple, as shown here. The staple limits the travel of the pin. With the staple holding the pin in place, the shaft may be rotated 180 degrees, exposing the opposite end of the pin, as you can see. The spring, washers, and nut may be replaced on the trip pin. Once the nut has been replaced, the workman checks the distance from the face of the nut to the end of the trip pin. He compares the measurement against the recorded figures he obtained before the trip pin was disassembled. The measurement now should match the earlier measurement. As with the opposite end of the trip pin, the nut is secured with the U-lock staple to prevent the nut from turning during operation of the turbine. It is extremely important that this assembly function correctly, as it could be the only safety device between normal operation and a runaway. The pin assembly should be tested to ensure that it is moving freely in its fit in the governor case. This can be accomplished by depressing the pin with a screwdriver, as shown here, and then allowing it to snap back. Now that the overspeed trip pin assembly has been replaced, our next step in the reassembly process will be to reinstall the constant speed governor. These are the parts of the governor. Step number 1 will be to slide the governor bearing onto the end of the spindle, as shown here. The workman then locks the bearing in place with the nut and washer. The nut is secured by prick punching it, like this. Now the governor bearing case is placed over the spindle bearing and seated properly. The spring seat, spring, and adjusting nut are then slid onto the spindle in their proper position. And the grommet seal is snapped into place on the spindle, as shown. Now slide the spindle assembly part way into the governor case, but not all the way in, since the weights must be installed first. The weights are installed by simply sliding them into place through the slots in the governor case as shown here. Make sure the knife edges are positioned properly. Once you have the 3 weights in position in the governor case, hold them in position with one hand while you slide the spindle assembly into place with the other. Make sure the spindle bearing case is seated firmly against the weights, holding them in place before you release the weights. Then start the adjusting nut to hold the spindle assembly in place. Once you have the nut started, you can release your hold on the weights. This particular turbine is equipped with weight stops, which must be reinstalled on the governor case at this time. The weight stops prevent the weights from moving out too far during operation of the turbine. Now measure from the face of the adjusting nut to the end of the governor case to make sure that the adjusting nut is back in its original position. The measurement should be the same as the one taken before disassembly. Check the position of the weights during this procedure to be sure they are not binding. Now that the main body of the constant speed governor has been reassembled, check the weights for proper operation. This is done by prying the end of each weight out from the case, as shown, and allowing it to snap back to its original position. Watch the spindle and other governor parts very closely as you do this to ensure that they are working smoothly. The workman has replaced the jam nut on the spindle and is measuring from the face of the jam nut to the end of the spindle. This measurement must compare with the measurement taken during disassembly. Be very careful to ensure that your measurement is accurate. The next step is to replace the spindle connection and to tighten the jam nut against it, locking the connection in place. Since both the overspeed trip pin assembly and the constant speed governor have been reassembled, the rotating assembly is now ready to be replaced in the turbine case. The workman is lowering the rotor to within approximately an inch of the case, guiding the oil rings to prevent their being damaged.